It is possible to determine that a quadratic function is an exact model for the data. The determination is going to rely on finding differences between certain values of the function. So first we're going to look at the spreadsheet that's set up over here on the side, and I'm going to do it down here on the bottom as well. The first column, or my first row, is going to represent the x values from 1 to 6. So I'm writing 1, 2, 3, 4, 5, and 6. Okay, and the values in the cells for columns B are actually going to be the y values for the equation 2x plus 7. So if I substitute in the 1, I get 2 times 1, which is 2, plus 7, which is 9. Okay, if I substitute in the number 2, I've got 4 plus 7, which is 11. And I can keep going, and I will have 13 and 15 and 17 and 19. So this was my x value, and this was my y value, okay, in my table here. All right, now what I'm going to do is I'm actually going to do some subtractions here. I'm going to say, I'm going to take the second term, which is 11, and I'm going to subtract 9. And what that gets me is a positive 2. And if I take 13 and I subtract 11, I get a positive 2. If I take 15 and subtract 13, I get a positive 2. 17 minus 15 is also positive 2. And 19 minus 17 is a positive 2. Now, because we only went to a first set of differences, we only went one time. If we went any further, we would just have all zeros. So our first set of differences got us matching numbers. We know that this is going to be a first degree polynomial. So this first line indicates to us that this is going to be a linear equation. And with linear equations, it not only tells us what the exponent's going to be, it not only tells us it's going to be y equals mx plus b, but it also tells us what the slope is going to be. So it also tells us that the slope is 2. So that's what ends up getting us. We have the slope, we have some points, we could substitute that in and figure out what the b value is, and that's what would end up getting us the equation of 2x plus 7.